In every era, humanity builds tools that reshape the way we think, create, and communicate. Today, one of those tools is the GPT, a Generative Pre-trained Transformer. But behind the headlines and the hype, what actually is a GPT, and how is something this powerful created? To understand the GPT, we must begin with a simple truth. A GPT is not a brain, not a consciousness, and not a mystical intelligence. It is a mathematical engine, a vast neural network trained to recognize and generate patterns in human language. At its core, a GPT is a function that takes text as input, transforms it into numbers, processes those numbers through billions of interconnected parameters, and predicts the next most likely piece of text. That's it, prediction repeated at extraordinary scale. A GPT understands language by breaking it into tokens, small units that may represent a character, a syllable, or a word fragment. Every token becomes a number, every number becomes a vector, and every vector flows through a structure called a transformer. This architecture uses a mechanism known as self-attention, allowing the model to examine every part of a sentence simultaneously, weighing relationships between words, meanings, and contexts. This ability to attend to everything at once is what gives GPTs their remarkable fluency and coherence. Now that we know what a GPT is, let's build one, step by step, as if we are creating it right now. The first step is defining the objective. We decide what the model should be capable of: understanding natural language, generating coherent responses, solving reasoning tasks, or assisting with complex workflows. This decision determines the model's size, the data set we need, and the computational power required. Next, we design the architecture. We choose how many layers the model will have, how many attention heads each layer contains, the size of the embeddings, and the total number of parameters. These parameters begin as random values. They hold no knowledge, no structure, no meaning. They are the blank canvas on which the model will learn. Then comes the data set, the raw material from which the model forms its understanding of language. We gather large collections of publicly available text, books, articles, code, scientific papers, and diverse human conversations. But raw text is not enough. We clean it, filter it, remove duplicates, eliminate harmful or low-quality content, and normalize formatting. Every piece of text is then tokenized, converting it into numerical sequences the model can process. With the data set prepared, we begin pre-training, the most computationally intense phase. Here, the model is exposed to billions or trillions of tokens. Its task is simple: predict the next token in a sequence. Every time it predicts incorrectly, the model adjusts its parameters through gradient descent, a mathematical process that nudges the network toward better performance. This cycle repeats trillions of times. Over weeks or months of training, the model gradually internalizes the statistical structure of language. It learns grammar, facts, reasoning patterns, and writing styles, not because we explicitly teach them, but because they emerge naturally from the patterns in the data. After pre-training, the model is powerful but raw. It can generate text, but it does not yet behave the way humans expect. So we move to fine-tuning. Here, we train the model on curated examples of correct behavior, answering questions clearly, following instructions, and avoiding harmful or misleading outputs. Human experts write demonstrations of ideal responses, and the model learns from them. Then comes reinforcement learning from human feedback. We generate multiple responses to the same prompt. Human evaluators rank them, and the model learns to prefer the better ones. This step aligns the model with human values, expectations, and communication norms. Next, we evaluate the model. We test it on reasoning benchmarks, multilingual tasks, coding challenges, and safety assessments. We identify weaknesses, retrain specific components, and iterate until the model reaches the desired level of reliability and capability. Finally, we deploy the model. We compress it, optimize it for speed, and integrate it into applications. We add guardrails, monitoring systems, and safety layers to ensure responsible use. Once deployed, the model continues to evolve through updates, new training cycles, and real-world feedback. This is the true, scientific, end-to-end process of creating a GPT. Defining the objective, designing the architecture, building the dataset, pre-training the model, fine-tuning it with human feedback, evaluating it rigorously, and deploying it responsibly. A GPT is not magic. It is the result of mathematics, engineering, and the collective knowledge encoded in human language. It is a tool, powerful, transformative, and still evolving, built not to replace human intelligence, but to extend it. This was the full understanding of what GPT is and how actually is created. If you found this video impressive and if you want to see more videos like this, so make sure to subscribe into the channel and like the video because we're worth it.